Today's topic is quadratic form to canonical form using orthogonal transformation. Okay. In this, reduce the quadratic form to a diagonal canonical form and also find rank, index, signature, and nature. Nature of the quadratic form. Already in my one of the video, the nature of the quadratic form, it has been explained. Okay, so that is the without canonical form. Now using canonical form, how to find the nature of the quadratic form. So this problem one already it is in the video, so I'm going to directly go with the canonical form. This already we have studied. Okay, so now lambda we got 2, 3, 6 the eigenvalues. Using the eigenvalues we got the eigenvector, normalized model matrices and n transpose orthogonal and we have calculated the diagonalization and canonical form also we have written. Okay, so till here we have completed. So from this how we have to find the nature of the quadratic form. So how we have to do it means, first step rank. Rank is denoted by the symbol R. So check in the question. So the final quadratic form we have to check it, or diagonal form we can check it. The diagonal forms are nothing but the eigenvalues. Okay, both it is common. The eigenvalues or canonical form both are same when you do it in a quadratic to canonical conversion. Okay, so both are same only. So when you have all the three parameters are positive, so then the rank is 3. Okay. So the index is nothing but the number, the index is denoted by the symbol P. So number of the positive terms, number of the positive terms or number of the positive value in the eigenvalues. So how many positive values I have? 3 positive values I have. Okay. So index is 3. Signature, we have a formula. It is 2p minus r. So 2 r and p we have calculated. 2 into 3 minus 3. So 6 minus 3, 3. Okay. So what is the corresponding condition for finding the nature? First case, when all the values are same. Okay. So all the values are same. For example, R, P and this signature is denoted by the symbol N. R, P and N. All the three values are same. Okay. So all the three values are same. R equal to P equal to N. All are same. Then it is a positive definite. Okay. Next case. So next will be positive semi-definite. Semi means one of your value should be 0. Okay. So your P, if index, okay, P is nothing but index. Index, in a index, any one of your value is 0. The eigenvalue, one of your eigenvalues are 0. If one of the eigenvalues are 0, eigenvalue 0, okay, but R equal to P, Then we say that it is R equal to P. Okay. Sorry, R is rank. Okay, rank should be greater. One of the eigenvalue is 0. The eigenvalues are positive. Then we say that positive semi-definite. We'll be using the condition to be R is less than N is less than signature. Okay. We will tell like this. Okay. So it is a positive definite. Positive semi-definite. When you have negative eigenvalue. Okay. If the eigenvalues are negative, then we say that negative definite. So it is R. Okay. Fourth case, one of the eigenvalue is 0, but the eigenvalues are negative. It's called negative semi-definite. All other cases are indefinite. The eigenvalues are negative. Let's see how to get it. Okay, R is less than N. This and all you need not check at all. Only when all rank and index and signature all are same, only positive definite we need to write. Separate for rank, index and signature, for that each one mark. Okay, so the nature finding it's 1 mark. So all other cases are indefinite. So in this, it is a negative semi-definite. One of the values 0, negative semi-definite. Okay. So completed. But our question, what was our question? All the are equal. So answer will be, in the nature will be positive definite. Nature is positive definite, 1 mark. Rank is 3, P is 3 and signature is 3. So like that you have to write it. This 4 condition you have to write it. Okay. Thank you.